Today, Andrew and myself will be talking more about how we can help customers deploy more critical workloads on GKE. And two features and products we're going to be talking about is backup for GKE, which is of the hyperscalers, one of the first features to be able to protect workloads in Kubernetes itself. And then a follow-up feature is how we can enable customers to use file share or file store more efficiently across multiple pods. So those are the two features, and I'll try to be quick so you can actually see a demo of the product when Andrew gets on it. So quick intro, I lead product for container and hybrid storage for Google. Andrew? Andrew's the tech lead for backup for GKE.
Yeah.
A couple of things we want to cover. We want to talk about, as we see customers moving their workloads to GKE and containers, where they are starting to see some of the friction and where are they asking us to address some of the challenges. So talking about scaling the workloads itself and what are the corners that we see customers asking us to round up and finish. Other pieces around when customers bring in their tier 1, tier 1.5 workloads, a lot of workloads are blocked by being able to achieve their data protection services. So what products we have around there, we want to touch on that. Then touch about a new feature, Filestore multi-share, and then a demo. That's the quick agenda for the next 27 minutes. Okay, so a couple of key data points, what we're starting to see. Kubernetes is no longer an early stage. It's crossed the chasm where customers are deploying tier 2, tier 1.5, tier 1 workloads on containers itself. And with 5.6 million developers, which is 67% increase year over year of users for containers itself, the scale at which the containers are being deployed are actually tremendous. And one of the challenges customers are running into is, how do you standardize the operations? It's no longer scripts that can scale for that level of operations. Customers are looking for more polished, more integrated, more scalable tools to be able to manage that level of clusters and pods that they're running in to deploy their workloads. So with that in mind, a couple of key use cases that we've been hearing from customers is Kubernetes definitely helps accelerate the pace of deployment for applications. But as you pace things up, the possibility of things going wrong also go higher, like application upgrades may not go as planned. So how do I roll back my application to a T-X state quickly? How do I test my upgrades before I even deploy my application? Can I make a copy of my production, deploy a test environment, test all my upgrades, then deploy in production? How do I do that? How do I scale my application for seasonal spikes, Black Fridays, Christmas, depending on the industry, there are spikes that are happening. How do I scale up across regions and how do I scale down across them? And of course, the more traditional use cases around how do I protect against zonal, regional failures and archive my data for long-term retention. So those are all use cases where customers are asking us, how do I address these challenges for workloads deployed in GKE itself? With that in mind, we recently announced a new product, and as far as I know, the first of across the hyperscalers, a Google native backup for GKE product. It's a product which is built straight into the GKE itself. So customers can, as a part of their cluster creation, as a part of workload deployment, they can set backup policies. So it's a Google native product to be able to protect containerized applications and their data. There was a talk earlier about what about application substrate and the data, and how do you orchestrate a backup or a DR scenario across the two itself. So as we go into the product and the demo, you'll see the product is built not just to protect the storage or the volumes that are attached to an application, but be able to capture the state and the Kubernetes objects that are needed to restore the entire application itself. So the biggest thing that we're hearing from customers is this blocks the next wave of workloads that were still on-prem because they were missing how to achieve the DR or the backup scenarios from regional zonal failures and the use cases. So this should unblock, or this is unblocking, given what we are hearing from customers already, that set of workloads to move to the cloud. It's a fully integrated, as I mentioned, it's the experience, as you will see in the demo also, is completely a first-class GCP experience. You, as a customer, you have complete control over scope of backup. You can back up an entire cluster. You can set a policy to say, every new cluster that I create has a backup. Or you can go in much more fine-grained control. Like we see multiple patterns of customers deploying applications. Customers may use an entire cluster for an application. Customers may use one cluster, but share it across multiple applications with namespaces. Or they can go to a much more granular level and say, these pods are my application itself. So,
quick question. You are talking about make backup of ZKS, sorry, and ZK, sorry. And the way to enable backup, whatever, is only permitted by the user interface, or there is a CRD in a kind of way I can I say I can pass the control to developers. Yeah.
So
yes.
the short answer to that, there's a little bit of a hybrid.
Okay.
Our control plane is in GCP. It's not in Kubernetes.
Not in Kubernetes.
So you can't initiate a backup with a CRD in Kubernetes.
Okay.
But what you can do is provide application level orchestration of a part of the backup. So anytime a backup includes your scope, you can control how that bit is backed up. And then we also have a delegated admin that allows the cluster admin to allow you to initiate backups of just your stuff.
There is some kind of policies that can.
Yeah, exactly.
So the use case Andrew mentioned, delegated admin, is as a cluster admin, you can say the backup happens every day at midnight, let's say.
Yeah.
But I'm an app admin and I'm doing a very critical upgrade at 2 in the afternoon.
Yeah.
So my last backup was yesterday. So as a cluster admin, you can say, Manu, I'm going to give you a delegated admin role. You cannot change any policies, but you can take an incremental backup in the same policy. So that's the delegated admin role that Andrew mentioned, that you can, as a part of the upgrade process, you can say, take a backup, then you start the upgrade process.
Yeah, but you must act in using this the Google console,
Google
right?
API.
There's obviously we've got command line.
Not inside the Kubernetes classes.
But we have Google Cloud command lines also.
So inside the application, though, so the fun use case would be that I should be able to run my application, instead of just doing typical red-green, I'm going to come back and I'm going to say, like, yeah, I've got some kind of a response saying, like, trigger the backup, wait for confirmation, run the upgrade, clean, and then if we have to roll back, then we know, like, we technically could have the entirety of the rollback fully automated, including the data rollback. Now that's like super advanced. I'd love to see the person that could do it outside of this room. Of course, you being the one that could probably do it, but I like that idea. But then that gets into delegation into the orchestration layer, not to the meatware.
Right. So again, we have 2 points of this. We have, of course, command line support, G-Cloud support for all this, so it can be scripted. You have to do some pre-set up for the delegated admin to allow you to have control over your bit. Plus, you can do this application-specific orchestration if you need to execute hooks and stuff, and you might talk about that in the presentation.
I'm going to talk about that in the slides.
But yeah, it's all something you can do if you've got the chops.
Right on. Yeah, no, it makes sense. Thank you.
So speaking of that, so is it like for an application backups in the old world, you would quiesce them, take a backup? Are you going to cover that for the cluster, for the containers, for the namespace, or?
So the short answer is we have a CRD where you can define a whole bunch of different stuff. It's pretty complicated, but it's pretty flexible.
I'm sorry, what's a CRD?
I'm sorry, CRD is in Kubernetes. It's called a custom resource definition. So we've invented a new type of resource in Kubernetes that you can use to say, okay, here are the bits that make up my application. Here are hooks that I want you to run in these containers as part of the backup process to do flush and quiesce activities. And then it'll release those, after the snapshot part of the volume backups is done. And yeah, so there's a lot to that.
So who is this? Who is the intended user for this? Is it anybody that is developing content, anybody that's using an application?
I think the primary user is the cluster admin. And then the secondary user can be app admins that are looking at upgrading or maintaining the system itself.
And so when you do that, and they're making changes. So they say, oh, let me make this snapshot or backup, as y'all are calling it. And do those get their own, are those identifiable for this is a backup? Is it doing the differences? Or if I'm an admin that comes in and says, I'm going to take a backup here, he comes in, I'm going to take a backup here, then we have a disaster. Do we have both of those snapshots to look at? Are they full backup snapshots, or like what do they all?
So our backups are, generally speaking, first one's full, all the others are incremental at that point, but they're standalone, which means even if you delete earlier ones, any one backup is all you need to be able to do a restore from.
So we manage incrementals versus fulls completely on the back end.
And are those, and hopefully you'll show, are those identifiable? So like if he does one and I do one, and
I think we'll walk through the demo and
you can name
set
it,
individual
and then
policies.
auto-scheduled ones have a timestamp as part of the name. So
Yep.
And restore can be to different clusters, different namespaces.
Use
all that
their
stuff.
different regions,
region
different clusters. Yeah.
across regions. Like one of the big use cases a lot of customers ask is, I want to migrate my application from region A to region B, take a backup and restore. I want to migrate my application from storage type A to storage type B. You can actually even take storage application, say, I want to move it from PD balance to PD SSDs. Sure. When you restore, you can change that and your storage class will be PD SSD.
Are they exportable backups?
Not at this time.
Not
That's a roadmap item.
potentially. So
Sorry. On the roadmap for the roadmap.
Does this work for Outpost as well, or Anthos? I'm sorry.
that's something we're exploring, but at this time it is for GKE only.
Yeah, it would be a different product. This is specifically for GKE on GCP.
So customers can, to your earlier point, you can operate with flexibility. You can take a backup in one region, restore another region, use it for scale. Also, one of the key use cases a lot of customers asked us was about ransomware protection. So once you take backups, how do you protect them from getting deleted? So one of the features we added to the product was being able to time lock the backups. And you can say that you can set a policy that all the backups that are created with this policy, they're locked for like a week or 30 days, whatever the comfort time period is. And even to the point, if somebody tries to delete a project, we will actually put a lien on the project that the project cannot be deleted unless the time lock expires.
Actually, so just to revisit that one question, you talked about GKE. Is it only GKE in Google Cloud, not GKE anywhere? I'm presuming there's storage layer primitives that are needed in order to do this.
Right. So today it is backup for GKE.
Right.
So Anthos, which is Google's multi-cloud.
Right.
Container management piece.
Sorry, and so you said Anthos. I was thinking it was like because they called it GKE anywhere, and then but it is. I want to make sure it's the right name.
Yeah.
You've always knows better than me. I ask dumb questions.
Time lock is not able to be deleted, not able to be overridden, not able to be what?
So they can never be overridden. So once you create a backup, the only thing that is modifiable on it normally would be a description tag or something like that. So you can't otherwise do anything other than delete a backup. So what time lock does is keep you from deleting the backup.
And so do normal backups without time lock have some sort of expiration date or?
Yes, you can set up an auto expiration. If you have scheduled backups, you have to set up an auto expiration. But you can also, for reasons that he mentioned, you can decide, look, maybe I normally expire them after 30 days, but I want them to always exist for at least 14 days, because if I get a bad actor in my network, I don't want them to be able to nuke my clusters and my backups, which they would be able to do even if there was an auto expire, unless you had it locked.
And the backups exist on the same cluster as the GKE?
Backups are not in the cluster, backups are in the cloud.
They're completely in our back
Once
plane.
the backup is taken, it has no dependency on the cluster.
So it's within the same AZ, same.
You can choose.
No, you can choose where to store them. Yeah.
We will cover. I think so. You have complete dependency of if you have data residency policies. You can say my backups are only in this region and we'll store them only in this region. You can choose it to be the same region, across regions, whatever the policy you're trying to get at. But it's in your control. Okay, so this was a bit more deep dive into the layers across which the backup works. So the backup software works across 3 different layers. The bottommost layer is any block data that is sitting on Google persistent disk. We'll grab a copy of that. Today, we're looking at supporting Filestore in future. So we'll pick up any copy of data that is sitting over there to be backed up. Second place is then you move to the cluster layer, and this is where a user can define, do you want to back up an entire cluster, a namespace, or an application? And depending on the scope of the backup user has defined, we'll pick up all the Kubernetes objects, PV/PVC mappings, replica counts, everything that is needed to restore that will be picked up. And the piece that Andrew was alluding to is the application, which is a custom definition that a user can define to say, this is my application. And once you define an application, you have flexibility to be able to define pre-backup and post-backup hooks. And this is where if a customer wants app consistent backups, you can define any pre-backup logic and post-backup logic to be executed. So it really is operating at the data layer, the Kubernetes objects layer, and optionally, if you want to crash consistent backups at the app layer itself. App consistent, yeah. I'm going to quickly cover the other feature before we jump to a demo, which is Multiwriter storage for Filestore. So
I noticed cloud storage wasn't part of that data plane. You've got persistent disk and Filestore, but not object.
So for, the way we're looking at it is, we're looking at least initially is how do we protect the primary volumes for the pods. So for the most part, GCS
Primary
is used.
volume cannot be an object store bucket.
You cannot boot things off, or most of the databases I'm running on either on file or block. I'm not putting databases in GCS yet.
So you absolutely, from inside an application hosted on Kubernetes, have your data be in object storage. He's not saying that. What we're saying is that in Kubernetes, storage as a first-class entity is always block or file surfaced through PVCs and PVs. So what we do is back up the disk underneath a PVC PV.
You don't think a persistent volume can be a bucket?
Yeah, so to be clear, are you referring to CSI, right? The container storage interface, right?
CSI, and how it manages
CSI in the earlier also, the general ecosphere around Kubernetes storage. Right.
Right. So you wouldn't use an object storage for a CSI. I don't even know if
you can't. Not without doing something like a fuse driver to make it look like it.
But you can do some way of like exporting backups into an object store, like
that is in fact what we of course end up storing all of this stuff in is object storage.
Right. So that there's a fundamental difference between a persistent volume and a backup of the persistent volume.
Right.
Right. I think that's where the confusion may be, right? Because we're talking about two different types of storage within a Kubernetes system.
It's also quite reasonable that you might have storage for your application that's actually a separate managed database. You might have storage for your application that is in a GCS bucket. You might have things that look like storage that aren't block and file. Those things today, we don't back up as part of the backup. What we back up is what looks like to Kubernetes.
A PV/PVC.
Right. Those are application layer data connections that are outside of any CRD. That's right. That's why you can't possibly know what the link is.
Exactly. We have no way to know that you're even using them.
And you can't retain consistency to them. It's application level consistency you have to maintain.
Right. Yep. There is another product that there is a Gcp-Wide Backup and Dr product. So if a customer wants to orchestrate a backup across, let's say, a Kubernetes cluster and a Cloud SQL database, they can orchestrate that at that level. But the backup for GKE is essentially, as Andrew described, more focused on block and file.
Yeah, I'm really excited to see it in the demo, and we've been talking for a while. So
okay,
our own fault. We keep taking them into the questions.
No, all wonderful questions. And so another piece is also Filestore. So Filestore can be used with GKE clusters. And one of the things customers have been asking us, how ability to share a single instance across multiple Filestore, multiple pods. So what we have is a capability where you can have a Filestore instance and use CSI to share that with multi-shares. It provides you multiple flexibilities. You actually have quick failovers because you have multi-attach. You don't have to wait for detach and attach. You can have multiple pods reading and writing. A lot of applications like brownfield applications which are moving to the cloud that require logs to be shared across multiple pods. This is one way they share logs across. And then it also has it also gives you higher availability. So what the new feature allows you to do is you can create smaller shares up to 10 gigs. So instead of spinning up an instance, you actually can just share across. So that's just another way we unblock like a lot of brownfield applications coming to the cloud.
Let me set the context a little bit. What we've got, I've created 2 GKE clusters. They happen to both be in the same zone, but they wouldn't have to. That's just for convenience for setting this up. And then what I've got is in one of these clusters, I am running an Nginx deployment. That Nginx has a logs disk associated with it, right? So what I'm going to do is I'm going to back up from that source cluster and restore into a target cluster. So that's going to be the context of the overall demo. And then I'll kind of walk through the product as I do it. So any questions before I start on this? Nope, you said go, go, go. Quit talking, more demo. Got it. So the first thing, this is the backup for GKE tab you can see here. So the first thing to understand is the data model. Everything in backup for GKE, you build a plan first, and then you do the thing that triggers it actually to happen. So a backup plan, think of it as the description, the configuration of a line of backups, and then a backup is the actual instance of individual backups. So almost all the time, what you're going to do is set up a backup plan and then set a schedule in that backup plan for automatically creating over time. You can have more than one backup plan for a cluster. You can have more than one backup plan that backs up the same things out of the cluster. And then restore plans, they're similar for on the restore side. And we'll talk about those things as we get to them. So I'm going to create a backup plan. So the cluster I'm going to back up from is the source cluster. I'm going to give this thing a name. I'm just going to call it Nginx. And here's where my typing is going to be a problem. Nginx backup plan. I'm not going to bother with the description. Now, here's to the point earlier. I can choose where to store this line of backups. Any region that the service is active in that fits your org policy for allowable regions is selectable here. To keep, oh, sorry, go ahead.
Can you also choose that replication for that storage? So if I wanted to replicate that storage to a different region?
No. The short answer to that is if you want redundant storage of backups, you set up 2 backup plans, one for each of those target regions.
Thank you. Good to
know. In this case, to make the backups faster, I'm going to do it in the same region. But as you can see, there were multiple region options available.
No encryption options or anything like that?
Next.
So, in fact,
We know you tweet out.
yeah. So we have the scope question. Scope is defined for namespaced resources in the cluster. This is very esoteric. We always back up all cluster scope resources, but you get to define which namespace scope. In this particular case, I'm just going to select which namespace to back up. I happen to have this NS1, which is where I know I put the Nginx in. If you had protected applications, you did find that would have been an option. But we didn't actually define any here. So you have to explicitly say yes to backup secrets because they tend to be a little bit sensitive. We don't back them up by default, but we're going to say yes. By default, we will also back up the persistent volume. So the way to think about this is a backup is defining which Kubernetes resources you're backing up. If that resource is a PVC and you've selected this check, we're also going to go down to the underlying disk and back that up.
Just so we're clear, when we're talking about here, when we say the PV, we're talking about an external storage, which you can create a CSI connection to different PV storage solutions, right?
That is correct. Right now, we support GCE persistent disk.
So the majority, when we're, I just want to make sure we're clear when we're talking about like Kubernetes resources, right? We're talking about native Kubernetes resources, and then those that are connected via CSI would be considered something. The PV is a resource, right? But what is outside of it, inside of that data?
That's like right. So if you think about it, there's a Kubernetes domain, which are all of these blobs. We think of them as YAML files, right? And then one of those blobs refers to something that is the underlying storage system thing.
Yep.
And that we also back up that. So
Fantastic.
then you have a choice of encryption here.
Do you back that up natively or through Kubernetes?
Natively.
Okay.
By default, of course, anytime you store something in GCS, it's going to be encrypted. But if you want to do your own managed encryption key, you can supply that here. Then you also have to do some other things. You have to provide access to that key. And of course, if you revoked access later, we wouldn't be able to take your backups anymore. But that's available. We're not going to do that for here, but just to know it's available. So then you can set up a backup schedule. Not the friendliest mechanism for this right now. We're talking about some other things later, but for now, you can put in a cron schedule. And I'm going to say, hey, you know, at 3:15,
like that.
yeah.
I was just open a VI window to do it.
Hey now.
That should be next.
So, and then I'm going to have on the retention policy side, I'm going to say, look, for this purpose, I'm going to say keep these backups for 7 days and automatically delete them. The time lock stuff he was talking about is here. I am not going to set time lock because that's going to make it impossible for me to clean up my demo environment right away. But you could then prevent deletion. Obviously, your auto deletion needs to be larger than your deletion block. So normally you would expect to see an auto deletion at 30 days, 60 days, something like that. And a delete block would be for a shorter period because you're really trying to protect against that ransomware or a similar kind of attack. And then if I set this, I can actually even choose to lock this whole policy so that nobody else could come in, sneak in later and remove your delete lock.
So the policy becomes immutable.
The policy itself can become immutable, not just the implementation of it at the backup level.
What happens if you have an expired, like basically the life cycle of your keys are now older, like they disappear and your backup does not? You talked about like retention of encryption.
Yeah, it just means you can't get access to it, but you can't delete it either.
Right.
So, yeah. Yeah, you don't need a key. You don't need access to the encryption key to be able to delete it.
Right.
You just needed the access to it to be able to read it.
So are you able to, is there API access to this so that you could use another backup product to back this up?
No. There is API level access, but it's to this control plane.
And what if you lock yourself out and you can't get to your data?
If you lock yourself out because you used a CMEK key that you no longer have access to, or you haven't given us access to, or
Yeah, anything, any user.
that becomes a customer support question, I think, is the real.
Like, to work
We'll
that sounds like a you problem.
and say, hey, I created the situation, and we'll have to figure out how to, because there's no automated way that we want to allow.
One of the reasons is like once we take a backup, we store it in our kind of vault. So that is one of the reasons. Like if we have a copy of PD, that copy is completely independent of the life cycle of the PD itself. So nobody can go into PD control pane and say, oh, I see 6 copies, I'm going to delete 2 of them.
Yeah, I get it. And I think that all of that's fine, but that's why, you know, there's so many backup rules that come from the on-prem world. And this is the reason why, is because users do things and accidents happen. And yeah, so, okay, that's good to know.
Yeah, because on the native key, like one of the triggers I think of is if I were to delete a key, and it should say like, no, this is attached to archived backups, which are live. And if you do this, then our IP or recovery.
That is a completely legitimate feature that we don't have it, but we certainly should consider it. In fact, I'm almost positive the CMEK guys inside are working on it. So because this is going to be a cross class.
Right.
Not just for backups. I'm sure there are other implications of the key.
Because yes, of course, you give somebody that ability, then they can remove their own access or our access by accident. So, all right, so I've created a plan. So now I can, you know, one of 2 things happen. A, I've created a schedule. That's going to be automatically creating backups now at, you know, at 8:15 p.m. local time every day. But I'm going to go ahead and manually kick off a backup here. Now, all the policies already been set up. So really all I have to do is give this a name. So I'm just going to call this manual backup.
So this was where, like, if there are multiple backups, each of them is a separate chain. So there are 2 people taking backups, and there are 2 separate policies. They're completely different chains.
Yeah, the idea is that we said chain. Chain is a term that's used in the underlying PD snapshot, but it also applies to our backup. So you get incrementals after the first one at the volume layer.
So if you wanted a one-time like outside of the policy structure, let's say that it had like a 45-day and the default was 7, you would have to actually create a new plan in order to do it.
Yeah.
Okay.
Yeah.
Ideally, we would recommend just customers if you set a policy, and then if you want an instantaneous, click the instantaneous one, because that will keep the same chain.
Correct. Yeah.
You
No,
don't
it makes
have-
sense. Yeah.
Yeah.
But again, just thinking of the meatware that we're going to think like, I want this one to last longer, but it would force you to say, do I really need it to last?
Do I really exactly?
So, I mean, what happens if you have a bad actor manage to gain access to the root Google account and just delete it?
That's actually what the
Time lock is.
the root account, if you will, in cloud is this project. And if you time lock, we actually put a lien on the project, so you can't just delete the project.
Unless that backup exists and the backup time lock expires, the project cannot be deleted.
So there are multiple steps to have to be able to make that possible.
Okay.
I'm just waiting for the backup to complete.
Yeah, Google Cloud is really cool.
Okay, so this backup has
Yeah, but
finished.
people are stupid and some people are bad. Like some people don't know what they don't know. There's user error still with this. And I can see lots of ways where there can be some very bad implications just from doing backups for a really, really, really long time.
So I'm going to create a restore plan now. And the idea is the restore plan is used for a particular restore scenario against any backup produced by that backup plan. So the idea is you can pre-create the restore plans. You don't actually pull the trigger on the restore till you need to, but you pre-configure it. So under the heat of the moment, when you have to do a restore, you're not having to worry about the configuration. So I'm going to go ahead and create a restore plan. I'm going to call this, I don't know, Nginx restore plan. And this is going to be a restore plan against this backup plan and into this target cluster.
So this is where you can choose cross clusters in the same cluster in the same namespace.
Yeah. Yeah, those clusters do not have to be in the same region. They can be, so you can actually have 3 different regions. The source region where your original cluster is, where you store your backups, and where you restore to. And all of that's controllable with org policy resource location constraints. So now there are a lot of configuration options at restore. I'm going to go over these fairly quickly, but I can't do full justice to it. The first is scope. It's very similar to the original. I'm going to choose all namespace resources because I only backed up one namespace, so it's safe to do them all. I'll do fail on conflict because I know that namespace doesn't exist in the target, but I could also choose a rollback, which you would do if you're going back into the same cluster and you want to sort of nuke the things first. I have a question about how I want to handle data. The obvious, the normal is the option that's pre-selected, which is create new volumes from the backups and wire those into the target cluster. But we have a couple of other options too, one of which is, hey, just create fresh volumes, don't actually restore the data. And then finally, the last one is useful in a narrower set of circumstances, but that says, look, just keep the old volumes. They're still around. Maybe I had a problem with upgrading my Kubernetes version in my cluster, but the volumes are fine. I just want to reuse those volumes in my target cluster.
So for that scenario, could you also use that to restore a backup and give access to that to a different application, to that data to a different application?
Oh.
So like if I'm doing AI/ML and I have a library that somebody's done some stuff on, and then I want to share that with a different group to do some more stuff on.
So the short answer is this is not just data. This is the whole Kubernetes package, data and
Okay.
resources.
Okay.
But how you deliver that into the target cluster and the use for it, yeah, there's all kinds of possibilities.
Sure.
So one of the things we talked about, CI/CD pipelines, like maybe you want to bring a production copy of stuff into your staging environment to make sure that's legit. Right. So, yeah, sure.
Yeah, so let's go back to projects really quickly, because if we're talking about what's in a project, you have, the restores in the project, you have the clusters in the project, all of this stuff is in the project, right? Disaster scenario happens when those clusters are gone. It feels like you're putting all of your eggs in one basket. So how do you defend against that in terms of making those backups available for a different project?
So that is a completely legit question. We don't support that now. We are talking about supporting cross-project storage of backups or restore of backups. So we're refining that. We have absolutely heard that.
Like that's one of the patterns we start to see. Like, so customers limit applications to certain pods, namespaces, clusters.
Yep.
We also know they have actually different projects. If they're running like multi-tenant applications for their customers, they separate across and they want to back up all of that from a centralized console. So that's
one
definitely
of the things we're looking at is GK has this fleets idea where you can register multiple clusters across multiple projects into a sort of single management framework. And that's probably what we'll want to leverage for this.
Okay.
Because it makes the IAM stuff a lot easier to deal with. So otherwise it would be really tough to set up.